G'day folks, Andy here from Aussie Homesteads, and today we're going to be talking about these things. Gas regulators. What do they do? How do they work? And why do you need one? Well, I'll tell you. The thing that prompted me to make this video was that fridge that you just saw in there was a 180 litre Dometic classic 3-way fridge, and it runs on gas, 12 volts or 240 volts. And when we acquired it, we paid $100 for it. And I trotted off to the gas place and I said to the lady that was there, I said, I need a gas regulator for my gas fridge. And she said, what size do you want? And I said, well, what size do they come in? She said, well, they're all 2.75 kPa. And I thought, well, that's wonderful. I mean, they've all got 2.75 kPa or 2.8 kPa printed on them. So I thought, well, that's okay. But what I neglected to do was to check the amount of kilograms per hour that those things can deliver, and they come in different sizes. Again, they're all 2.75 kPa, and this is actually the one that I got for that gas fridge. This is the one they supplied me, and it's 3.5 kilograms per hour. That's what it's capable of delivering off. That doesn't mean it's going to deliver 3.5 kilograms per hour, but it's capable of doing that. Now, in your gas bottles is 2,000 kPa or 2,000 kilopascals. Okay, that's a 9 kilo bottle. And it has to be able to step it down from the high pressure of 2,000 kPa in there down to 2.75 kPa, which is a dramatic drop when you think about it. You're going from high pressure to low pressure. So all of your gas appliances have to have one of these things in the line, and that's a gas regulator. So on the left is your standard fitting. This is called a POL fitting, which actually stands for Presto Light, but they're just known as POL fittings. And they fit internally into the gas bottle. So that's an internal threaded bottle. Now you'll notice one thing in Australia, we're starting to come up with these new bottles, and they have both fittings on them. They have what's called an external thread, and that's known as an LCC27. That's its technical name. But it's an external thread and an internal thread. So you've got a choice between whether you use an internal POL fitting, or the new regulators now come out with these external fittings that are quite easy to put on because you only have to screw it on about 3 or 4 times and she's there. So that's the difference between your POL and your LCC27 fittings. But let's go back to the kilograms per hour. It's all fine and well that they run at the same pressure, but pressure does not equal volume. Now, let's have a quick look at the different types of regulators that we keep at the farm. Now, this one is, again, 2.75 kPa. They're all low-pressure regulators. And you can always tell a low-pressure hose because when you go and order something, it's always bright orange now. That's how you know that that's a low-pressure gas line. Okay, so let's look at the different ones. This one is 1.5 kilograms per hour, 2.0 or 2 kilograms per hour, 2.5 or 2.5 kilograms per hour, 2.8 kilograms per hour, but yeah, wait, it gets worse, 3.5 kilograms per hour, and the biggest one that we have is 4 kilograms per hour. Now, what would you say you had a little 3-way fridge, say a 60-litre 3-way fridge? I'll go and show you one. This is the little 60-litre gas fridge. It's a 3-way, 12 volt, 240, and gas, and it's actually piped to a regulator that's outside. And this one we generally run on gas. This is the one we keep in the powerhouse. We're going to make a TV games room in here. I'm going to do a full video on that. You'll see that shortly. Okay, so back to regulators again. So what size would I put on my 60-litre fridge? It would either be try the smallest ones first. So 1.5 kilograms per hour is way more than enough to run that 60-litre fridge, I can assure you. As a rule, and this is a general rule of thumb, if you're running like a stovetop or anything that's fairly low on consumption, just choose 2.0 because it's the most commonly available one. Okay, so the problem with that big fridge was I neglected, as I said, to check how many kilograms per hour. Now, according to the manufacturer, it should run on a 9 kilo gas bottle for 667 hours. Now, they don't say whether that's on low or medium or high, but I'm going to assume that that would be on low. So 667 hours is 30 days. But I didn't check what was on the regulator, and I connected that fridge up, put her on to full bore, And 24 hours later, that thing was frozen solid. It was rattling through the gas. Well, within 4 days, it had dumped a whole bottle out. It had literally burnt through a whole bottle in 4 days. Now, it's not supposed to do that. It's supposed to run on low for 30 days, remember? And then that prompted me to scratch my head and think, well, I'm going to go around the farm. I'm going to check every regulator. Why is it that this one is rattling through so much gas? And it turned out it was that thing there, the gas regulator. So remember that they all run at 2.75, 2.8 kPa or kilopascals, but that doesn't equal what the volume that they can push out. Now, what happens if you want to run 2 appliances on the same gas bottle? Well, you can buy these things, and they're just a T. This is a POL fitting T. That joins into where your 9 kilo bottle right there. So you can join that into there, and you can pipe 2 off of that, okay? Now, when you're running 2 items, it is going to use a little bit more gas. So you might want to go from 2 kilos to say a 2.5 or even a 2.8. But try those first and run both items at the same time and see if they'll run on the 2.8 kilograms per hour. Remember, it can deliver 2.8 kilograms per hour maximum. So also, how do they work? Well, what I'm going to do is in the comments, I'm going to pin a link to a 1 minute and 15 second, I think it is, animated video on how these regulators work. But basically, you've got your high pressure side on this side and your low pressure on that side. And that's what side the hose goes onto, and that goes onto your item. And inside those things, they have a rubber diaphragm in there, and it's got a metal disc on the back of it with a very strong spring in there. And when the gas comes in from the bottle, and turn the bottle, the gas goes in the bottom and it pushes the diaphragm up, but it's got to fight against that spring. And eventually those two will balance themselves out to 2.75 kPa. And then it will deliver constantly, because now it's given a constant flow of 2.75 kPa out that end. So check out the animated video. It's actually quite cool. But anyway, that's what prompted me to make this video. So there you go. It's Andy here from Aussie Homesteads. I'm going to sign out until the next one. I hope that helps someone to size up their gas regulators. Andy here from Aussie Homesteads signing out, and I'll catch you up on the next one.